Slowing aging. What the science says, according to Dr. David Sinclair, can we slow or even reverse human aging? Recent discussions between Stanford neuroscientist Dr. Andrew Huberman and Harvard geneticist Dr. David Sinclair reveal that the science behind slowing aging is evolving, though no miracle cures exist. Their conversation covered epigenetics, mitochondria, caloric restriction, exercise, sauna use, and experimental cellular rejuvenation approaches. Here are 6 key takeaways from their discussion and their implications for health. Aging isn't just wear and tear for years. Aging has been framed as the gradual accumulation of cellular damage. Sinclair argues this is incomplete. The DNA sequence itself remains relatively stable, but the epigenetic software that regulates gene expression degrades over time. This software consists of chemical and structural marks that tell cells which genes to activate. When it becomes disorganized, cells lose identity and function, even with intact DNA. This leads to the information theory of aging, suggesting aging is an epigenetic information loss. A 2025 study showed distinct DNA methylation patterns become disordered with age across multiple organs. Essentially, gene networks become less precise, reducing biological information available for maintaining function. Sinclair's work, including a 2020 Nature study, showed partially reprogramming retinal cells in mice restored youthful gene expression and reversed vision loss. While preliminary, it suggests some age-related epigenetic changes may be reversible. Mitochondria. The cellular power grid mitochondrial decline is central to aging. These organelles generate cellular energy, and their function deteriorates with age, producing less energy and more damaging reactive oxygen species. This dysfunction is linked to muscle loss, neurodegeneration, and cardiovascular disease. A key regulator of mitochondrial function is NAD+, essential for energy production and DNA repair. A 2013 Cell study showed NAD+ levels fall with age, impairing communication between the nucleus and mitochondria. Restoring NAD+ levels improved function. While NAD+ boosters like nicotinamide riboside, NR, and nicotinamide mononucleotide, NMN, can raise NAD+ levels, no study has yet proven they slow aging in humans. However, the underlying biology justifies continued research. Caloric restriction. A controlled stressor caloric restriction, CR, shows promise, but isn't a magic bullet. In worms, flies, and rodents, CR reliably extends lifespan and delays age-related diseases. This involves nutrient-sensing pathways like mTOR, AMPK, and sirtuins, which shift cells into repair mode when energy is scarce. Human trials are limited, but the CALERIE trial showed modest caloric restriction, 12% less, reduced blood pressure, LDL cholesterol, and inflammatory markers. Overeating suppresses cellular repair, accelerating damage. Sustainable periods of reduced intake may improve health, but extending lifespan remains unproven. Exercise, non-negotiable for longevity. If one intervention is nearly universally agreed upon, it's exercise. Sinclair calls it non-negotiable, and the evidence is overwhelming. A Taiwanese study of 400,000 adults showed as little as 15 minutes of moderate exercise daily reduced all-cause mortality by 14% and added roughly 3 years of life expectancy. Higher activity levels continue to show benefit. Mechanistically, exercise stimulates new mitochondria, improves insulin sensitivity, reduces inflammation, and activates pathways influenced by caloric restriction. Heat, cold, and hormesis. Stress as a catalyst. Sinclair and Huberman discuss hormesis. Short, tolerable stressors trigger adaptive responses. Heat exposure has the strongest human data. A 20-year Finnish study showed 4 to 7 sauna sessions weekly reduced risks of sudden cardiac death and fatal heart disease. Cold exposure shows promise in small studies, improving insulin sensitivity and mitochondrial function. The bottom line, practical steps for patients. No miracle cures exist. NAD+ boosters and epigenetic reprogramming remain experimental. However, the science points toward a coherent framework linking cellular mechanisms with actionable interventions. Clinicians should reinforce fundamentals: nutrition, movement, sleep, and stress management. Emerging therapies targeting aging biology offer potential, but caution is advised. Ultimately, we aren't on the verge of immortality. But if the science continues to hold up, more people may reach advanced age with better health, vision, muscle strength, brain function, and independence.